Welcome back, guys, to another loose nut printing video. This video is going to be a mixed bag of everything. So first thing we're going to be doing in this video is we're going to be removing the heated bed to fix the issue we found in last video, and that's the bed being slightly on the warp side. So the first thing we're obviously going to have to do is remove it from the printer and get the sensor off. Checking here with the straight edge, you can see running a flashlight on the backside how that gap increases. If I held that straight edge actually in the center, you would have seen it on both sides, not just one. And now with the plate being tweaked back into position, you can see how that light isn't as prominent. There is a few low spots, but it's a lot better than what it was. So now with it semi-tweaked back into right position, we can get it remounted onto the printer and give it a shot at bed mesh to see how well we actually untwisted this poor thing. But it's definitely going to need to be replaced. Going to be presetting the bed at 15 mils at every corner and going from there. And so going to home the printer first to make sure the probe's in the center of the bed, and you can't really do anything in Klipper until you home that bed. And then I did Z-tilt to make sure both Z screws are in level of each other, parallel of each other, and then we just start to do a bed mesh here. We're going to just simply call this bed our mesh 1 and run the calibration to find out how skewed this bed is. And I got it set up to do a 5x5 grid to try to give as much accuracy as possible. I think I'm going to increase the probe count. I think I'm going to go to a 7x7 just to give a bit better read. And with the first bed mesh in, you can see how the one side is still far down. A lot better than what it looked like the first time around, but definitely has some room to improve. So with a good baseline now, we can just adjust the screws a little bit on the corners that seem low, and we can run another bed mesh test, and we'll find out how this one looks. With this one in, getting better, but definitely needs some room. So I'm going to do a little bit more off camera here. A few more done. You can see slowly into position. There is still that one little high spot. And with about 22 bed meshes later, I was able to get something like this. So with this one being good, I'm going to delete all the previous ones and now save this one as the bed mesh we're going to use. Now we're going to go into the printer config and double check that it did save the bed mesh, and it looks to be good. So now I'll just real quickly here show you what I did for my bed mesh setup. I use speed of 50. I'll probably lower it a little bit. Horizontal move is 15 to get the probe out of the way, and you can see how the bed mesh, like I was mentioning in previous video, small numbers first, large numbers last, and then everything else is like the fade, how many times it does it, things like that. So now with all that done, we'll now calibrate the probe or nozzle again, since it's changed since we removed the bed. And with that mesh or offset right, we'll save it and update the config. Double check that the config's updated, and it did. Perfect. So now with that changed, we can set our Z minimum. We couldn't set it until we had our Z probe offset. And now with the Z minimum set, we can add a couple of things to Z here. We want to be doing a second homing to get a better Z mesh or Z probe offset. And then the other thing, we're going to be adding a couple lines to the bed leveling. We're going to do 3 samples of probing the bed when we're doing home, we're going to make sure it takes the result of the middle probe. So whichever out of the three is the middle number, it will use that. And here we're going to tell it its tolerance. I left it loose here for now. I did change it later once I got finished with everything. And then tolerance retries is how many times it's going to try it until it fails. If it does 4 times and it can't get a good number, it's just going to zero out. So next thing, with all that done, now we're going to be repositioning where 0, 0 is on the printer. Right now the nozzle can move past the corner of the bed. And if we went and tried to print, we'd be starting the print off in the middle of no man's land. So we have to relocate the nozzle and tell it where maximum distance is. And that's what we're doing here, is just double checking that those numbers are correct. And it looks to be good. So with those done, we next can move on to doing a extruder test. And simple little test, just to make sure that we're pushing the right amount of plastic. Everything should be technically good here, since I am using the Voron Legacy's config for the tool head. So I shouldn't need to adjust anything. And looking at it, and well, at 100 millimeters, it's right flush with the top of the tool head. Perfect. So we don't have to change anything there. Now with that done, we can now move on to doing a PID testing, or tuning I should say, for the bed. Since I'm going to be primarily printing PLA PETG with this printer, I'm going to be doing the calibration at 60 for now for PLA. I'll probably come back to redo this for PI tuning for PETG. But it's best to do PID tuning just to get the temperatures more stable and consistent. So we're just going to simply let the bed heat up. And then once I did that, you can see that the targeted temperatures actually are changing and fluctuating. It's going to tell it to go to 50, wait for, see how long it does that, then reheat to 60. And so I'm going to do that for about 5 minutes, 5-10 minutes. And once it's got that done, it's going to spit some numbers out. You can see on the console. With those, you just simply save, and boom, it's ready to go. And when I was trying to do PID tuning for the tool head, I was running into that error message you've seen. And what the issue was, actually, it wasn't to do with the targeting temps were too low or too high, or yeah, the high was being too low. The issue was I was trying to target too high of a temperature. I was trying to do 250 for PETG, but right now it looks like the heating cartridge cannot sustain that temperature. So I had to lower the temperature down to 210 to be able to at least get a PID or 220, I mean, for doing tuning for the tool head, unfortunately. So just makes the whole idea of doing a 24 volt update to this printer much more of an idea, because I thought I could get away with running it on the 12 volt with PETG, but not. So the tool head's going to take about the same length as the bed, about 5-10 minutes, and once it has finished, you'll see it will spit out different PID numbers, and with those you just simply save it, the config, and boom, now you have your PID tune. One thing I didn't realize I could do with Klipper until later on after doing everything was a probe accuracy. And that will actually be one of those things you want to do right off the start, just to see if your probe is drifting out of sync, if it's going too large or too small. And you could see this one was actually pretty good. But that's pretty much all for this video. If you guys enjoyed this one, rate, comment, and subscribe. I'll see you again in the next video. Have a good one.